Hello, and welcome to the Sleepy Physicist. I'm so glad you found your way here tonight. Whether you're settling into bed with curious thoughts swirling through your mind, curled up on the couch with a warm drink, or simply trying to unwind after a day filled with the relentless tick-tock of clocks and schedules. This is your quiet corner of the internet where physics gets gentle, where profound questions meet soothing voices, and where the deepest mysteries of our universe are explored with the kind of care you'd give to a delicate flower. Tonight we're diving into one of the most profound questions that has puzzled philosophers, physicists, and poets for centuries. It's a question that touches the very core of your existence, influences every moment you experience, and yet remains so elusive that some of the greatest minds in history have reached completely opposite conclusions about it. We're asking whether time itself is real, or if it's nothing more than a beautifully persistent illusion that our minds have constructed. Now, I do hope this exploration isn't quite so fascinating that it keeps you wide awake. But if it does, well, at least you'll drift off with some rather extraordinary ideas dancing through your thoughts. Before we begin this gentle journey through the nature of time, if you enjoy these slow, contemplative adventures into physics, I'd be ever so grateful if you tapped that like button, subscribed to join our community of curious minds, or simply left a comment telling me where in the world you're listening from and what time it is in your corner of the universe. There's something wonderfully poetic about people across different time zones pondering the nature of time itself. All right, take a deep breath, let your shoulders relax, and let's begin our quiet voyage into the mystery of time. Picture this moment, right now, as you're listening to these words. It feels immediate, doesn't it? Present, real. This moment seems to have a special quality, a nowness that separates it from your memories of breakfast this morning or your plans for tomorrow. But what if I told you that this feeling, this sense of now, might be one of the most convincing tricks your brain has ever played on you? The question of whether time is real strikes at something so fundamental to human experience that it almost feels absurd to even ask. After all, you age, seasons change, flowers bloom and wither, and your coffee grows cold while you're distracted by a fascinating conversation. How could something so obviously real be an illusion? Yet here we are, living in an era where our best scientific theories suggest that time might not work the way our intuition insists it must. Let me tell you about a letter that changed how many people think about time. In 1955, Albert Einstein, perhaps the most famous physicist who ever lived, wrote a letter of condolence to the family of his dear friend, Michel Bessot. In that letter, Einstein penned what would become one of the most quoted and misunderstood statements in physics. For us believing physicists, the distinction between past, present, and future is only a stubbornly persistent illusion. Now, that's quite a thing to say in a letter meant to comfort the grieving, isn't it? But Einstein wasn't being callous or philosophical for the sake of it. He was expressing a view that had grown from decades of revolutionary discoveries about the nature of space and time. His theories of relativity had revealed that time is far stranger, far more flexible, and far more interconnected with space than anyone had ever imagined. But here's where it gets interesting and perhaps a little controversial. While Einstein's quote is often used to support the idea that time is an illusion, some physicists argue that Einstein himself never really believed time was illusory in the way many people interpret that famous statement. The physicist Tim Maudlin suggests that if Einstein had truly thought his theories proved time was an illusion, it would be rather odd that he would only mention such a monumental conclusion in a private note of condolence, rather than in his scientific papers. This disagreement points to something fascinating about the nature of time in modern physics. Even among the brightest minds, there's no universal agreement about what time actually is or whether it's fundamentally real. Some embrace what's called the block universe theory. Others argue for the reality of time's flow, and still others propose that time emerges from more fundamental, timeless processes. So tonight we're going to explore these different perspectives with the curiosity of children and the patience of philosophers. We'll wander through Einstein's revolutionary insights about space and time, peek into the strange world of quantum mechanics, where particles seem to dance outside the normal flow of time, and examine what your own brain is doing when it constructs your personal experience of temporal reality. The block universe theory, which grows out of Einstein's work, presents a view of reality that's both mathematically elegant and profoundly unsettling to our everyday experience. Imagine, if you will, that all of time, from the Big Bang to the heat death of the universe, exists as a single four-dimensional structure. In this view, time is like space. Just as all points in space exist simultaneously, the north and south, east and west of our world, all moments in time exist simultaneously too. Your childhood birthday party, the moment you're experiencing right now, and events that won't happen for 1,000 years are all equally real in this block universe. They're just located at different temporal coordinates, much like how London and Tokyo are both real cities, even though they exist at different spatial coordinates. From this perspective, the flow of time, your sense that the present moment is somehow special and that the future is yet to be determined, is indeed an illusion created by consciousness as it encounters different slices of this eternal, unchanging block. This isn't just abstract philosophy. The block universe view emerges naturally from Einstein's special and general theories of relativity, which have been tested and confirmed in countless experiments. When Einstein showed that simultaneity is relative, that two events which appear to happen at the same time from one perspective might occur at different times when viewed from another reference frame, he effectively demolished the idea of a universal present moment that everyone in the universe could agree upon. Consider this thought experiment that physicists love to contemplate. Imagine there's a future manned mission to Mars, and mission controllers on Earth are wondering what Commander Jones is doing at Alpha Base right now. Looking at their clocks showing noon, they might conclude that the commander is eating lunch. But here's the strange part. An astronaut zooming past Earth at nearly the speed of light could look at his own clock at that same moment and, depending on his direction of travel, determine that the time on Mars is either earlier or later than noon. The astronaut might say the commander is still cooking lunch or has already moved on to washing dishes. This relativity of simultaneity makes a mockery of any attempt to identify a special, universal present moment. If there's no universal now, then all moments must be equally real, which leads us directly to the block universe where past, present, and future coexist in eternal stillness. But the strangeness doesn't end there. Einstein's theories also revealed that time itself is flexible, stretching and compressing depending on motion and gravity, in ways that would have seemed like pure fantasy to earlier generations of scientists. Time dilation, as this effect is known, means that time literally moves at different rates for different observers. The faster you move through space, the slower you move through time, relative to someone at rest. At everyday speeds, this effect is utterly negligible, but as you approach the speed of light, time dilation becomes dramatic. A traveler on a spacecraft moving at 99.9% the speed of light would experience time passing normally from their own perspective. But to someone watching from Earth, that travelers' clocks would appear to tick incredibly slowly. This isn't science fiction. We see time dilation in operation every day in the global positioning system satellites orbiting our planet. These satellites must account for the fact that their clocks run slightly faster than clocks on Earth's surface, due to both their high speed and the weaker gravitational field they experience. Without these relativistic corrections, GPS would accumulate errors of several miles per day. Even more dramatically, gravity itself warps time. The stronger the gravitational field, the slower time passes, relative to regions with weaker gravity. At sea level, you age 1/1,000,000th of a second less each year than you would if you lived atop Mount Everest. It's a tiny effect, but it's real and measurable with precise atomic clocks. Near a black hole, these temporal distortions become extreme beyond imagination. If you could somehow survive approaching a black hole's event horizon, time would slow so dramatically that from your perspective, the rest of the universe would appear to age eons in moments. Meanwhile, to observers watching from a safe distance, you would appear to slow down and freeze at the edge of the black hole, your image growing redder and dimmer until it faded from view. These aren't just mathematical curiosities. They represent fundamental features of reality that challenge our most basic intuitions about time. If time can speed up and slow down, if simultaneity is relative, if the past and future might be as real as the present, then perhaps our everyday experience of time truly is a kind of illusion, a compelling but ultimately false impression created by limited perspective. Yet not everyone in the physics community accepts this conclusion. There are respected physicists who argue passionately that time is not only real, but fundamental to understanding how the universe works. They point to processes like quantum measurement, thermodynamic irreversibility, and cosmic evolution as evidence that time has a genuine direction and reality that can't be dismissed as mere illusion. The debate continues. And tonight we're going to explore both sides of this profound question with the kind of gentle curiosity that allows for wonder without demanding immediate answers. We'll discover how your brain constructs its own version of temporal reality, why a cup of coffee cooling in your kitchen might hold clues to time's deepest nature, and what the latest discoveries in quantum mechanics suggest about the relationship between consciousness and time itself. But before we dive deeper into these mysteries, let's pause for a moment and simply appreciate how extraordinary it is that we can even ask these questions. Here you are, a collection of atoms that formed in the hearts of ancient stars, somehow organized into a pattern complex enough to contemplate its own existence in time. Whether time is real or illusory, whether it flows or stands still, this moment of curiosity, this gentle exploration of reality's deepest puzzles, is something rather wonderful indeed. So let's wander a little deeper into this temporal labyrinth, shall we? Because if time truly is this flexible, malleable thing that Einstein described, then we need to examine what that means for the most intimate aspects of your existence. After all, you don't live in the abstract world of physics equations. You live in a world of deadlines and birthdays, of watching sunsets and counting heartbeats, of memories that feel distant and hopes that feel urgent. The question becomes, how do we reconcile the mathematical elegance of relativity with the undeniable reality of lived experience? This is where things get deliciously complex, like trying to understand a symphony by examining individual sound waves. Both perspectives are true, yet they seem to describe entirely different universes. Let me share with you one of the most beautiful examples of time dilation in action, one that brings these abstract concepts right down to human scale. NASA once conducted an experiment with twin astronauts, a real-life version of Einstein's famous twin paradox thought experiment. One twin spent extended time aboard the International Space Station, orbiting Earth at about 7,500 miles per hour, while the other remained planted firmly on our planet's surface. When the spacefaring twin returned, scientists discovered something remarkable. Due to the effects of both speed and the slightly weaker gravitational field experienced in orbit, the astronaut twin had aged about 5 milliseconds less than his Earthbound brother. 5 milliseconds. That's barely perceptible. Less time than it takes for a hummingbird to flap its wings once, yet it represents a fundamental truth about the nature of time itself. This tiny discrepancy whispers of something profound. If time can slow down by 5 milliseconds during a relatively modest journey through space, imagine what happens at the extreme edges of the universe. Near the event horizon of a supermassive black hole, time doesn't just slow down, it practically stops altogether from the perspective of distant observers. Picture this scenario, if you will. Imagine you're watching a brave, if perhaps foolhardy, explorer approach a black hole. From your safe vantage point far away, you would see something extraordinary and terrifying unfold. As the explorer draws closer to that point of no return, they would appear to move more and more slowly. Their movements would become languid, dreamlike, as if they were swimming through temporal molasses. From the explorer's perspective, however, everything would feel perfectly normal. Their watch would tick at its usual pace. Their thoughts would flow at their customary speed. But looking out at the universe around them, they would witness something spectacular and horrifying. The cosmos would appear to accelerate. Stars would age and die in moments. Galaxies would dance their billion-year waltzes in the blink of an eye. At the event horizon itself, this effect becomes infinite. From the outside observer's perspective, the explorer would appear to freeze completely, their image growing redder and dimmer as the light itself struggles to escape the black hole's immense gravitational pull. They would seem to hover there forever, suspended at the edge of eternity. Yet from the explorer's point of view, they would pass through the event horizon in a finite amount of their own time, falling toward mysteries that no information can ever reveal to the outside universe. This isn't science fiction. This is the reality described by our best understanding of gravity and time. Black holes are, in a very literal sense, gateways to the end of time, or as some physicists poetically call it, gateways to nowhen. They represent places where the normal flow of temporal experience breaks down so completely that the very concept of sequence, of before and after, loses its meaning. But here's where the mystery deepens even further. While Einstein's relativity reveals time to be flexible and relative, quantum mechanics, the other great pillar of modern physics, seems to tell a different story entirely. In the quantum realm, we encounter phenomena that appear to transcend the normal constraints of time altogether. Consider the phenomenon of quantum entanglement, which Einstein himself famously dismissed as spooky action at a distance. When two particles become entangled, they maintain a mysterious connection that seems to operate instantaneously, regardless of the distance separating them. Measure the spin of one particle, and you instantly know the spin of its entangled partner, even if it's on the other side of the galaxy. This appears to violate the speed of light limit that Einstein held as absolute. Information about the measurement seems to travel faster than light, which according to relativity should be impossible. It's as if entangled particles share a connection that exists outside the normal flow of space-time, in some timeless realm where cause and effect operate by different rules. Some interpretations of quantum mechanics take this strangeness even further. The many worlds interpretation suggests that every quantum measurement splits reality into multiple branches, each representing a different possible outcome. In this view, there isn't just one timeline flowing from past to future, but an infinite number of parallel timelines, constantly branching and diverging like the limbs of an impossibly complex tree. If this interpretation is correct, then the question of whether time is real becomes even more perplexing. Which timeline represents the real flow of time? Are all possible histories equally valid? Does time flow differently in different branches of reality? The mathematics works beautifully, but the implications stretch our concepts of temporal reality to their breaking point. Then there's the measurement problem in quantum mechanics, which suggests that the act of observation itself somehow collapses the quantum wave function, transforming a superposition of possibilities into a single, definite outcome. This seems to imply that consciousness plays a fundamental role in determining reality, including the reality of temporal sequences. Some physicists have proposed that consciousness and time are intimately connected in ways we're only beginning to understand. The quantum physicist Roger Penrose and anesthesiologist Stuart Hameroff have suggested that consciousness itself might operate through quantum processes in microscopic structures within neurons called microtubules. Recent experiments with anesthetized rats have provided intriguing evidence for quantum processes in the brain. Scientists observed the re-emission of light over hundreds of milliseconds to seconds, far longer than classical physics would predict, suggesting that neurons might indeed be capable of quantum operations. If consciousness does operate through quantum mechanisms, then perhaps our experience of time's flow isn't just a psychological illusion, but a window into the quantum nature of reality itself. This brings us to one of the most profound puzzles in modern science: the hard problem of consciousness. How does subjective experience, including our intimate sense of time's passage, arise from the objective, mathematical descriptions that physics provides? If space-time emerges from more fundamental, timeless ingredients, as some theories suggest, then how does conscious experience, so deeply tied to our perception of temporal flow, arise from these non-temporal foundations? It's a question that sits at the intersection of physics, neuroscience, and philosophy, and it doesn't have easy answers. But it points to something remarkable about your existence. Every moment you experience, every memory you cherish, every anticipation you feel about the future represents a kind of miracle. Somehow, the universe has organized itself in such a way that it can experience itself subjectively, can feel the passage of time from the inside. Whether time is ultimately real or illusory, whether it flows or stands still in some eternal block universe, your experience of temporal passage remains one of the most extraordinary phenomena in all of existence. You are, in a very real sense, the universe becoming conscious of time, of change, of the subtle dance between memory and anticipation that we call the present moment. And perhaps that's what makes this question so captivating and so important. In exploring the nature of time, we're not just investigating an abstract physical phenomenon. We're trying to understand something fundamental about what it means to be conscious, to exist, to experience reality from the inside. We're asking not just what time is, but what we are, and how our subjective experience relates to the objective reality that physics describes. As we continue this gentle journey through the mysteries of time, we'll discover how your brain constructs its own temporal reality, why the simple act of a coffee cup cooling might hold profound clues about time's ultimate nature, and what the latest discoveries about the relationship between information, entropy, and temporal flow might tell us about whether time is real or simply the most persistent and beautiful illusion ever crafted by consciousness. But for now, simply rest in the wonder of this moment, this inexplicable nowness that seems to separate the remembered past from the anticipated future. Whether it's real or illusory, it's yours to experience, and that experience itself is something rather magnificent indeed. The strangest part about all of this might be that while physics reveals time to be this flexible, relative, and possibly illusory phenomenon, your brain has constructed what feels like the most stable, consistent experience imaginable. Every morning, you wake up with a clear sense of yesterday flowing into today, with memories arranged in neat chronological order and expectations about tomorrow that feel perfectly reasonable. How does this happen? How does your mind create such a convincing sense of temporal flow from what might be nothing more than a static, eternal block of space-time? Let's take a gentle stroll through the neuroscience of time perception, because what happens inside your skull when you experience time might be even more mysterious than what Einstein discovered about the universe at large. Your brain, it turns out, doesn't have a single clock ticking away the seconds like a metronome. Instead, it operates more like a jazz ensemble, with different neural networks keeping their own rhythms and somehow harmonizing them into the seamless symphony of temporal experience you call consciousness. At the heart of this process is something called your circadian rhythm, controlled by a tiny cluster of neurons in your hypothalamus called the suprachiasmatic nucleus. This biological clock doesn't just regulate when you feel sleepy or alert. It provides the underlying tempo around which all your other temporal experiences organize themselves. But here's what's fascinating. This clock doesn't actually measure time in any absolute sense. Instead, it responds to light, to temperature, to social cues, creating a subjective rhythm that can drift and shift in ways that would make a Swiss watchmaker weep. You've experienced this temporal flexibility yourself, haven't you? Think about how time seems to crawl during a boring lecture or a long wait at the doctor's office, yet flies by during an engaging conversation or a captivating movie. An hour of objective time doesn't translate precisely, or even approximately, to an hour of psychological time. Your brain isn't tracking absolute duration, it's tracking information and experience, and it's especially sensitive to perceived novelty. This is why childhood summers felt endless while adult years seem to rush past in a blur. When you're young, everything is new. Every experience is being cataloged and processed with intense attention. Your brain is working overtime, creating rich, detailed memories packed with novel information. But as you age and fall into familiar routines, your brain starts to compress experiences, filing them away with less detail, creating the subjective impression that time is accelerating. There's something both beautiful and melancholic about this realization. The very mechanism that allows you to navigate through time efficiently by filtering out redundant information and focusing on novelty is also what makes your life seem to speed up as you accumulate experience. It's as if consciousness trades temporal richness for cognitive efficiency, a bargain that becomes more apparent with each passing year. But the brain's construction of temporal reality goes much deeper than simple novelty detection. Different emotional states actually change how you perceive duration in measurable ways. When you're afraid, your amygdala becomes hyperactive, speeding up what neuroscientists call your internal clock. This is why accidents often seem to unfold in slow motion, why threatening situations feel stretched and extended. Your brain is essentially overclocking itself, processing more information per unit of objective time, creating the subjective experience of temporal dilation. It's a fascinating evolutionary adaptation when you think about it. In moments of danger, when every millisecond might mean the difference between survival and catastrophe, your brain shifts into a higher temporal gear, squeezing more conscious processing into each precious moment. The irony is that this life-saving mechanism creates an illusion, the feeling that time itself has slowed down, when really it's your consciousness that has sped up. On the other end of the emotional spectrum lies the experience of flow, that wonderful state of complete immersion in an activity where self-consciousness disappears and hours can pass like minutes. When you're in flow, whether you're painting, playing music, writing, or engaged in deep conversation, your brain seems to abandon its usual temporal bookkeeping. The constant narrative of past, present, and future fades into the background, leaving only pure experience unfolding in an eternal now. This flow state might offer us a glimpse of what consciousness would be like if it weren't so obsessed with temporal organization. In flow, you're still aware, still processing information, still making decisions, but you're doing it all without the usual sense of time passing. It's as if you've temporarily stepped outside the stream of time and discovered that awareness itself doesn't actually require temporal structure to function. These variations in subjective time raise profound questions about the relationship between consciousness and temporality. If your brain can speed up, slow down, and even temporarily abandon its sense of temporal flow while remaining perfectly functional, what does that tell us about the nature of time itself? Is the temporal structure of normal consciousness just an organizing principle, a useful fiction that helps you navigate through experience, rather than a fundamental feature of reality? Consider what happens when you dream. In the strange theater of sleep, your brain constructs experiences that can feel like they unfold over hours, or even days, yet occur during brief periods of REM sleep lasting minutes. Dream time follows its own logic, compressing and expanding in ways that would be impossible in waking consciousness. You might dream of having lengthy conversations, traveling great distances, or living through complex narratives, all within the span of a short sleep cycle. When you wake, you often retain a clear sense of the dream's temporal structure, even though you know objectively that it couldn't have unfolded in real time. This suggests that your brain's temporal organizing principles are flexible enough to construct entirely artificial chronologies that feel completely real from the inside. If consciousness can create such convincing temporal illusions during sleep, might it not be doing something similar during waking life? The neuroscience of temporal perception reveals something else remarkable about your brain. It's constantly predicting the future and revising the past. Every moment of consciousness involves your brain making educated guesses about what will happen next, based on patterns learned from previous experience. When these predictions prove accurate, they're seamlessly integrated into your ongoing sense of temporal flow. When they're wrong, your brain quietly revises its model of what just happened, editing your memories to maintain narrative coherence. This predictive processing happens so smoothly that you're rarely aware of it, but it's fundamental to how you experience temporal continuity. Your brain is essentially writing and rewriting the story of your life in real time, creating the impression of a coherent timeline flowing from past through present toward future. But this timeline isn't a passive recording of objective events. It's an active construction, constantly being updated and revised to maintain psychological coherence. This brings us to one of the most puzzling aspects of temporal consciousness, the phenomenon of the specious present. When you examine your direct experience closely, you'll notice that the present moment isn't actually a single, instantaneous point. Instead, it feels like a brief duration, perhaps 2 to 3 seconds long, within which past, present, and future seem to coexist simultaneously. Within this specious present, you can be aware of the fading echo of a word you just spoke, the current word you're speaking, and the anticipation of the next word you're about to say, all at the same time. It's as if consciousness creates a small temporal window, a moving bubble of nowness that contains traces of the recent past and hints of the immediate future. This specious present might be the closest thing we have to a genuine temporal reality in conscious experience. It's not the mathematical point of now that physics might suggest, nor is it the extended duration of memory and anticipation that fills our broader sense of temporality. It's something in between, a brief span of lived time that feels simultaneously unified and dynamic. But even this seemingly fundamental aspect of temporal experience varies dramatically between individuals and situations. People with certain neurological conditions experience alterations in their specious present that can make the normal flow of consciousness nearly impossible. Some report feeling stuck in an eternal instant, unable to connect one moment to the next. Others experience time as fragmented, with each second feeling disconnected from those around it. These clinical cases offer profound insights into how the brain constructs temporal experience. They suggest that what you normally experience as the natural flow of time is actually the result of incredibly sophisticated neural processes working in harmony. When these processes are disrupted, the illusion of temporal flow can break down completely, revealing just how much work your brain does to maintain the sense that you're moving smoothly through time. Perhaps most intriguingly, there's growing evidence that the brain's temporal processing systems are intimately connected to its mechanisms for constructing a sense of self. The same neural networks that track temporal relationships also contribute to your sense of personal identity, of being a continuous self persisting through time. This suggests that your experience of temporal flow and your sense of being you might be two sides of the same cognitive coin. If this is true, then the question of whether time is real becomes deeply personal. Your sense of self, your memories, your hopes for the future, all depend on the brain's ability to organize experience temporally. If time is indeed an illusion created by consciousness, then in a very real sense, you are that illusion. Not in a dismissive way, but in the most profound sense imaginable. You are time becoming aware of itself, duration gaining the capacity for self-reflection. This realization brings us to an interesting paradox. If time is constructed by consciousness, but consciousness itself unfolds in time, which comes first? It's a question that pushes us beyond simple either-or answers towards something more nuanced and beautiful. Perhaps time and consciousness are co-emergent phenomena, each necessary for the other's existence, like dance and dancer or wave and ocean. The ancient Buddhist philosophers had an insight that seems remarkably relevant here. They spoke of the interdependence of all phenomena, the idea that nothing exists independently, but only in relationship to everything else. Perhaps time and consciousness, rather than being separate entities where one is real and the other illusory, are aspects of a more fundamental reality that transcends such simple categorizations. As we continue exploring these mysteries, we'll discover how the simple act of entropy increase, why your coffee grows cold and never spontaneously reheats itself, might hold the key to understanding time's apparent direction. We'll examine how information theory is revolutionizing our understanding of temporal flow, and we'll consider what the latest discoveries about quantum entanglement and consciousness might reveal about the deepest nature of temporal reality. But for now, simply rest in the wonder of your own temporal experience. Notice how your thoughts seem to flow from one to the next, how memories and anticipations dance around this moment of listening. Whether this flow is ultimately real or illusory, it's the stage upon which the entire drama of your consciousness unfolds. And that drama, that inexplicable fact of your aware presence in what feels like a moving moment, remains one of the most beautiful mysteries in all of existence. The universe has a peculiar habit of keeping secrets, and perhaps none more tantalizing than the mystery of why time seems to have a direction. You've never seen a broken cup spontaneously reassemble itself on your kitchen floor, never watched smoke flow backward into a cigarette, never witnessed a melting ice cube suddenly freeze solid in your warm drink. There's something about the way events unfold that creates what physicists call the arrow of time, a cosmic preference for one direction over another that seems to distinguish past from future in ways that the fundamental laws of physics don't obviously require. This directional quality of time brings us to one of the most beautiful and mysterious concepts in all of physics: entropy. Now, don't let that word intimidate you. Entropy is simply a measure of disorder, of how spread out and mixed up energy becomes in any system. And here's the remarkable thing: entropy almost always increases. It's like a cosmic law of messiness, a universal tendency for things to become more scrambled, more chaotic, more evenly distributed as time progresses. Picture your bedroom on a busy morning. You wake up with everything neat and organized, your books arranged on shelves, your clothes folded in drawers, your desk clear and ready for the day. But as you rush to get ready, entropy begins its inexorable work. Books get pulled out and left open, clothes get tried on and discarded, papers scatter across your desk. By evening, what was once ordered has become delightfully chaotic. Now, you could certainly clean up, restore order to your space, but notice what happens when you do. You have to expend energy, work up a sweat, perhaps get a bit frustrated as you search for where you left your favorite pen. In cleaning your room, you've decreased its entropy, but you've increased the entropy of yourself and your surroundings. The total disorder of the system has still gone up. This is the second law of thermodynamics in action, one of the most fundamental principles in all of science. In any isolated system, entropy tends to increase over time. It's what makes your coffee cool down rather than spontaneously heat up, what causes perfume to spread throughout a room rather than mysteriously concentrate back into the bottle, what ensures that scrambled eggs never unscramble themselves back into neat shells. But here's where it gets fascinating. This tendency for entropy to increase might be the closest thing we have to a fundamental explanation for why time has a direction. Entropy gives us an arrow of time, a way to distinguish past from future that doesn't depend on our subjective experience or psychological perception. The past is the direction of lower entropy, the future is the direction of higher entropy, and the present is where we find ourselves riding this wave of increasing disorder. Think about it this way. If you were shown a movie of smoke dispersing from a cigarette, you could immediately tell whether the film was playing forward or backward. Smoke that starts dispersed and gradually concentrates into a neat column would look obviously wrong, violating your intuitive understanding of how entropy behaves. The arrow of time is literally written into the way energy and matter organize themselves in our universe. But this raises a profound puzzle. The fundamental laws of physics, from Newton's mechanics to Einstein's relativity to the equations of quantum mechanics, are almost entirely time reversible. If you filmed the collision of two billiard balls and played the movie backward, the reversed motion would still obey the same physical laws. The equations don't care which direction time flows. So where does this directional arrow come from? Why does the universe prefer one temporal direction over another? The answer seems to lie in the initial conditions of our universe, in the particular way things were arranged at the very beginning of cosmic time. According to current cosmological theories, the universe began in an extraordinarily special state, what physicists call a low entropy configuration. All the matter and energy that would eventually become galaxies, stars, planets, and people was squeezed into an incredibly hot, dense, uniform state. Now, this might seem backward. How can a state where everything is squashed together be considered low entropy? Shouldn't maximum disorder mean everything is as mixed up and spread out as possible? Here's the subtle point. When gravity is involved, uniform distribution is actually a highly organized state. Under the influence of gravity, matter naturally wants to clump together to form structures and hierarchies. A universe where matter is spread perfectly evenly is fighting against gravity's organizing influence. As the universe expanded and cooled, gravity began to win this cosmic tug-of-war. Tiny fluctuations in density grew into the seeds of stars and galaxies. Matter clumped together, forming the complex structures we see today. But this process of structure formation, paradoxically, increases entropy because it allows matter to release gravitational potential energy, which then spreads out as heat and radiation. From this perspective, the entire history of the universe can be understood as a long, slow slide from the highly organized initial state toward maximum entropy. Stars form and burn, converting organized nuclear fuel into disorganized heat and light. Galaxies evolve and merge, dissipating their organized motions into random thermal energy. Black holes grow and eventually evaporate through Hawking radiation, turning organized matter into the most disorganized form of energy possible. This cosmic story of increasing entropy might explain not just why time has a direction, but why we exist at all. Life, consciousness, and intelligence are temporary eddies in this flow toward maximum disorder. Complex patterns that emerge in the brief window between the universe's organized beginning and its heat, death ending. We are, in a very real sense, entropy's children, complex structures that exist precisely because the universe is in the process of becoming more disorganized. But recent developments in physics suggest that this story of entropy and time's arrow might be even more fundamental than we previously imagined. The key insight comes from understanding entropy not just as disorder, but as a measure of information. Every time a system becomes more disordered, it's actually losing information about its initial state. The scattered papers on your messy desk contain less information about how they were originally organized than when they were neatly stacked. This connection between entropy, information, and time brings us to one of the most revolutionary ideas in modern physics: the possibility that information, not matter or energy, might be the universe's most fundamental currency. If reality is ultimately made of information, then the flow of time might be nothing more than the universe processing information, updating its own description of itself from moment to moment. In this view, what we experience as the passage of time might be the universe computing its next state based on its current state, like an impossibly complex cosmic computer running the program of existence. Each moment represents a new configuration of information, a fresh update to the universal database of what is real and actual. This information-theoretic perspective on time connects beautifully with our earlier discussion of quantum mechanics. When quantum systems become entangled, they share information in ways that seem to transcend normal spatial and temporal boundaries. Some physicists now suggest that quantum entanglement might be the mechanism through which the universe maintains its informational coherence, ensuring that all parts of reality remain synchronized even as time appears to flow. But here's where things get truly mind-bending. If time is really about information processing, then consciousness might play a more fundamental role in temporal reality than we ever imagined. After all, consciousness is essentially an information processing phenomenon. Your brain takes in sensory data, processes it, integrates it with memories, and generates the unified experience you call awareness. Could it be that consciousness doesn't just experience time, but actually participates in creating it? Some interpretations of quantum mechanics suggest that conscious observation plays a crucial role in determining which possibilities become actual reality. If this is true, then every moment of awareness might represent a genuine choice point in the universe's evolution, a moment when the future crystallizes out of the quantum foam of possibility. This brings us to one of the most tantalizing questions in modern physics: the relationship between consciousness and quantum mechanics. We mentioned earlier the work of Roger Penrose and Stuart Hameroff, who proposed that consciousness might operate through quantum processes in neural microtubules. Recent experiments have provided intriguing support for quantum effects in biological systems, including the brain. In these experiments, researchers studying anesthetized rats found evidence of quantum coherence lasting hundreds of milliseconds to seconds in neural tissue, far longer than classical physics would predict. This suggests that the brain might indeed be capable of maintaining quantum states long enough for them to influence neural processing. If consciousness does operate through quantum mechanisms, then it might have access to temporal relationships that transcend our normal understanding of sequential time. Consider what this might mean for your subjective experience of temporal flow. When you're deeply absorbed in a creative task, time seems to dissolve. Hours pass like minutes, and you feel connected to something larger than your ordinary sense of sequential moments. Could these flow states represent moments when your consciousness temporarily accesses quantum temporal relationships, stepping outside the normal arrow of time into something more fundamental? The implications are staggering. If consciousness operates through quantum processes that can transcend normal temporal sequence, then your experience of time's passage might not be just a psychological construction, but a window into the deepest levels of physical reality. You might not just be experiencing time, but participating in its creation, helping to determine which possible futures become actual through the very act of conscious observation. This perspective transforms the question of whether time is real or illusory. Instead of seeing these as mutually exclusive options, we might consider that time has multiple levels of reality. At the level of fundamental physics, time might indeed be emergent, arising from more basic timeless processes. At the level of thermodynamics and information, time might be the direction of increasing entropy and decreasing information. At the level of consciousness, time might be the rhythm of awareness processing experience and participating in the universe's ongoing self-creation. But perhaps the most profound insight comes from recognizing that all these levels are intimately interconnected. The quantum processes that might underlie consciousness operate according to the same fundamental principles that govern entropy and information. The thermodynamic arrow of time that makes your coffee cool creates the conditions necessary for the complex structures that give rise to awareness. And consciousness, in turn, might participate in determining which quantum possibilities become classical realities. This interconnectedness suggests that time, rather than being simply real or illusory, might be something more subtle and beautiful, a fundamental feature of how reality organizes itself across multiple scales, from the quantum to the cosmic. Time might be the universe's way of preventing everything from happening at once, as the physicist John Wheeler once quipped. But it might also be much more than that. Time might be the rhythm of existence itself, the cosmic heartbeat that allows complexity to emerge from simplicity, consciousness to arise from matter, and meaning to crystallize from possibility. In this view, your experience of temporal flow isn't separate from physical reality, but intimately woven into its deepest structure. As we near the end of our gentle journey through these temporal mysteries, it's worth pausing to appreciate the extraordinary nature of this moment you're experiencing right now. Whether time is ultimately real or illusory, whether it flows or stands eternally still, you are here now, aware and wondering about the nature of existence itself. That capacity for wonder, for questioning the fundamental nature of reality, might be the universe's greatest achievement, the point toward which all of cosmic evolution has been building. In the next and final part of our exploration, we'll consider what all these insights might mean for how you live your daily life, how understanding time's mysteries might change your relationship with mortality, memory, and the precious present moment. We'll discover that regardless of time's ultimate nature, there's something profoundly meaningful about the temporary patterns of complexity and consciousness that we represent. But for now, simply rest in the wonder of this temporal moment, this inexplicable nowness in which past and future meet in the miracle of present awareness. Whether you're experiencing the flow of time or time is experiencing itself through you, there's something rather magnificent about being here, now, contemplating these deepest mysteries of existence while the universe continues its ancient dance between order and chaos, information and entropy, possibility and actuality. So here we are, at the gentle conclusion of our journey through time's deepest mysteries, and perhaps you're feeling a bit like Alice after tumbling down the rabbit hole, wondering what any of this means for the simple, beautiful reality of your everyday existence. After all, you still have to wake up tomorrow morning, still have appointments to keep and people to love, still experience the poignant passage of moments that make up a human life. How do we reconcile these cosmic revelations about time's nature with the intimate reality of living within it? The beautiful truth is that understanding time's mysteries doesn't diminish the meaning of temporal experience. It deepens it. When you realize that your sense of flowing time might be consciousness participating in the universe's own self-creation, every moment becomes more precious, not less. When you understand that the arrow of time emerges from the cosmic dance between order and entropy, the simple act of organizing your thoughts or creating something beautiful takes on profound significance. Consider how this new understanding might change your relationship with memory. Those childhood summers that felt endless, the way certain moments seemed to stretch into eternity, while others flash by in an instant. These aren't just quirks of psychology. They're glimpses into the flexible, constructed nature of temporal experience. Your brain isn't passively recording time like a clock. It's actively creating temporal reality through the very act of conscious attention. This means that how you pay attention literally shapes your experience of time's passage. When you're fully present, deeply engaged with whatever you're doing, you're not just having a richer experience, you're participating more fully in time's creation. Those flow states where hours pass like minutes aren't escapes from time. They might be moments when you're most directly connected to time's deeper nature. And what about mortality, that most intimate consequence of time's apparent passage? If time is indeed emergent rather than fundamental, does that change how we understand the finite nature of human existence? In one sense, it might offer comfort. If all moments exist eternally in some vast block universe, then perhaps nothing is ever truly lost. Your first kiss, your child's laughter, the sunset that took your breath away, all might be preserved forever in the eternal structure of space-time. But there's something even more profound here. If consciousness plays a role in creating temporal reality, then your very awareness, your capacity to experience and remember and anticipate, represents something genuinely creative in the universe. You're not just witnessing time's flow, you might be helping to weave it into existence through the simple act of being consciously present. This perspective transforms how we might think about the precious brevity of conscious life. Yes, your individual awareness is temporary, a brief flowering of complexity in the universe's long journey from order to entropy. But that temporariness isn't a flaw or limitation. It's what makes consciousness so extraordinary. You are time becoming aware of itself, duration gaining the capacity for wonder and reflection. The physicist Carlo Rovelli beautifully captures this when he writes about how we are not in time, but rather time is in us, woven into the very fabric of our neural processes, our memories, our anticipations. The flowing river of consciousness isn't separate from temporal reality. It might be temporal reality at its most fundamental level. As you drift towards sleep tonight, perhaps carried by these gentle thoughts about time's nature, remember that regardless of whether time ultimately proves to be real or illusory, your experience of it remains one of the universe's most remarkable achievements. In you, billions of years of cosmic evolution have produced something capable of contemplating its own temporal existence, capable of love and loss, and the bittersweet beauty of moments that feel both eternal and fleeting. Whether you're experiencing the flow of time or time is experiencing itself through your consciousness, there's something rather magnificent about this moment of awareness you're having right now. The universe has organized itself in such a way that it can wonder about its own nature, can feel the passage of moments, can find meaning in the temporary patterns of complexity that briefly emerge from quantum possibility. So as we conclude this gentle exploration, know that you carry within you one of existence's deepest mysteries. Your sense of now, your memories of then, your hopes for what's to come, these aren't just psychological phenomena. They might be glimpses into the very heart of how reality creates itself, moment by precious moment, through the miracle of conscious awareness. Sleep well, dear listeners, and may your dreams dance freely through time's mysteries. Whether time flows like a river or stands eternal like a mountain, you are here now, aware and wondering, and that itself is perhaps the most beautiful thing the universe has ever accomplished. Until next time, I'm the Sleepy Physicist, and this has been Slow Science for Deep Thought. Until we meet again in another moment of this strange, wonderful, possibly illusory, definitely magnificent thing we call time. Good night. If you've enjoyed this gentle journey through temporal mysteries, I'd be so grateful if you shared your thoughts in the comments below. Where in the world are you listening from? And what time is it in your corner of the universe? And if you'd like more of these soothing explorations into physics' deepest questions, a like and subscribe would mean the world to me. Sweet dreams. And remember, whether time is real or not, this moment of connection we've shared is something rather special indeed. Rather special indeed.